Well, let's begin. Welcome everyone to the Faculty of Education Community Speaker Series. I'm Perry Klein. I'm the Associate Dean of Research in the Faculty of Education. The Community Speaker Series is a series of talks that we hold here in the Center Branch Library at downtown. And it's the researchers from our faculty, the Faculty of Education, and they come to talk about their research. And so we welcome a broad audience to those talks. How many people here are parents? That's good. How many people are teachers? So did you hear about this through the Board of Education email or website? Yeah, okay, good. How many people are from Western? Okay. How many people are other members of the public who aren't parents, teachers, or from Western? Okay, good, yeah. Well, welcome. So I want to introduce Dr. Barbara Fenesi. Dr. Fenesi has a PhD in psychology, kinesiology, and behavior from McMaster. She's also done a postdoctoral fellowship in kinesiology. Dr. Fenesi is a candidate for Canada Research Chair. Canada Research Chairs are prestigious researchers who are research leaders within Canada. And Dr. Fenesi is going to be a Tier 2 chair, so that's for early career researchers. Barbara has published numerous journal articles in top quality journals. And the two areas in which she's done most of her research are multimedia learning for children and adults, and also the role of physical activity in learning, which is what she's going to talk about tonight. Her research concerns how the entire human organism, both the brain and the body, play a role in student success. Besides her academic publications, Barbara's research has gotten a lot of media attention. So she's been written about in Forbes magazine, Huffington Post, as well as local newspapers. So I'll turn things over to her in a moment. So we have an hour for the talk. And would you like to take questions throughout the talk, or would you like to hold questions till the end?
Absolutely.
So questions throughout the talk? Yeah. Okay, good. Welcome, Barbara.
Hi, everyone. Thank you very much for coming. So it's usually a privilege for us as researchers to be able to share what we do with the community, because usually we're just talking to one another in our research. But I think at the end of the day, for most of us, we really want to translate our work to the community and get it in the hands of educators, students, and teachers, because our ultimate goal is to optimize student success. So thank you for being part of this. So just to give you a little bit of a rundown of what to expect in today's talk, first we're going to talk about the role of attention, and the role of attention specifically in student success. Now that might sound a little bit obvious. Of course, you have to be able to pay attention in order to do well in school, but it's actually easier said than done. There's a lot of things vying for your attention in a classroom. You have to sustain your attention for quite a long time, for an hour, up to 3 hours if you're in a university lecture. So there's a lot of demand on our attention to be successful learners. Then we're going to talk about physical activity and what role this plays in facilitating attention as well. And we're going to then put these two things together and actually look at the role that physical activity in a classroom environment can play in fostering greater attention and ultimately supporting student success. So our ability to pay attention is a critical life skill. So this is, you might take it for granted, but just something as simple as driving requires a lot of attention. You have to pay attention to the road, other drivers, stop signs, traffic lights. There's a lot of things in your environment that you have to constantly update and pay attention to in order to remain safe. If you want to be a good conversationalist, you have to be able to pay attention to what someone is saying in order to react appropriately. But in both of these cases, and in many other cases, these are just two, there's a lot of things in your environment that can be very distracting. As we'll become intimately aware of, weather conditions can lead to a whole lot of distractions in our environment when we're trying to drive. Then you have to take in different elements of the weather that, again, try to vie for your attention and can be challenging to focus on the task at hand. Also, if there are interesting conversations being spoken around you, those are also very distracting and can be pulling your ear in a certain direction, and the next thing you know, 30 seconds have passed and you've not been paying attention to what somebody's been saying, and that can be very awkward. So there's a lot of general life environments where you have to exert a lot of attentional control. But it's also very, very important when it comes to learning. So if we just think of just a few examples of when attention is really important in a learning context, when you have to listen to the teacher. I'm sure all the teachers in the room get weary saying pay attention, and that's because you're not going to be able to take in any information unless your attention is focused on the instructor. Your ability to ignore distractions, other peers talking in the environment, again, that's a really critical part where you have to focus attention and remain on task. When you're trying to focus on assignments, again, this can happen in a classroom environment, it happens when you're at home working on homework, but attention is a critical cognitive process in the learning process. And what's really interesting is that research in neuroscience, brain science, has shown that there is a particular region of the brain known as the prefrontal cortex that is very important in facilitating your ability to pay attention. And so what we see in different research studies is if people are doing very attention-demanding tasks like focusing on an assignment, and we stick them into a brain scanner, you'll see this prefrontal region of their brain light up. And what that means is there's a lot of blood flow to the region, and blood brings nutrients and oxygen and essentially resources to help that area function better. And so we see that this area is very important in attention. Now what's really interesting is that this same brain region, the prefrontal cortex, is also heavily involved in physical activity. So what you see is when kids play sports, they run around during recess, they play tag. If you were then to put them in a brain scanner again, you see the same brain region light up following physical activity. And what's really exciting about that is that we can see a really strong association between physical activity and attention. So what we find in the research is that if you are more physically active, whether you are a child, an adolescent, a young adult, an older adult, you are better able to control your attention. So before I give you some research to support that claim, I'm going to take a step back so you understand, well, how do we even measure attention in research? And we do it with a variety of different tasks, but one of them is called a Stroop task. So maybe the researchers in this room know what this looks like, but it's essentially a piece of paper that you get that has a bunch of words on it. Now the words are colors, but they're also written in a variety of different ink colors. So you can see purple here is actually written in red, yellow is written, I think it's supposed to be purple, let me just check what the actual color, no, it's supposed to be blue, and red is written in green. So the idea is that you can see there's an incongruency, there's a mismatch between what the color of the word is. So it says purple, but it's written in red. So your job in this task would be you get this piece of paper, and you have a whole bunch of words on it like this, and you have to read as fast and as accurately as possible the whole list of words. Okay, but when you see the word that's written, that says purple, but it's written in red, you actually have to say the color of the ink rather than the word itself. So you would have to say red, blue, green, rather than the word itself. Now why this is really challenging is because humans have a pre-programmed response to actually read the word. So you really want to read purple, yellow, red. You don't want to read the color of the ink. So it's a really good index into attentional control because you have to keep in mind what your task is. I have to read the color of the ink, and you have to inhibit that prepotent response, which is reading the actual word. So we're going to do a little demonstration so you can get a feel for what participants would be like in this environment. So you're going to see a screen that looks like this, and they're going to come fairly rapidly, and you have to say the color of the ink. So you would say green. Okay, and let's see how well we do. Okay, ready? And say it out loud.
Red. Blue. Red.
Yellow.
Blue. Green. Yellow. Green. Red. Blue. Red. Yellow.
How was that? It was tough, right? There were, like, for some, you got into a groove, but some of them are more challenging, like you would start to say the word and be like, oh shoot, I have to say the color. And you have an entire sheet of this that you have to read. So it becomes, challenging the more words that you get, but it's a really good indication for us as researchers how good you are at controlling your attention. And we can correlate and match your performance on these tasks with a whole bunch of different features and different tasks. But let me give you one more example. We also use what's called a flanker task. So if you were a participant, you'd be sitting in front of a computer screen and you'd see an array of arrows that look like this, and your job is to just focus on the central arrow, so the one right in the middle. And you have to indicate on a keyboard press, left or right, which way it's facing. Okay, this is pretty easy. They're all facing in the nice same direction. This one's also easy. They're all facing in the same direction. Occasionally, though, you'd see something like this. So now the surrounding arrows are actually incongruent to your target item. So now this trial becomes more difficult because the other things in the environment are distracting. So your ability to successfully and quickly say left in this condition is an indication of your attentional control. So you ready to be participants again? So again, just say left, right as quick as you can. Usually this is a computer-based task, okay? Now these are gonna go quick, so we might do it twice so you don't feel bad about yourself. Okay, that was rough, but usually in studies we actually give some practice trials so you get a feel for it. So this wouldn't be, your one shot at your attentional capacity. So we would give you a practice trial. But yes, do you have a question?
Do you compensate for people with color deficiencies or dyslexia?
Interesting. For the Stroop task?
For the two tasks, because someone with color deficiencies may take longer time to decide what a color is.
Yeah, so usually there is a pre-screening requirement when we have participants come into the lab that they don't have sort of color vision issues, that they're colorblind, just to avoid that, because I think that you wouldn't be able to, I guess you could use the other colors that don't interfere with that, but the flanker, I'm not really sure if it would, I guess it might. I'm pretty sure usually you pre-screen for any sort of abnormalities in that respect. But yeah, that was fairly challenging, but it does give us a good index, and these tasks are used for kids, for adults, for older adults, and they seem to consistently give us some insight into attentional capacity. So back to this point, if you're more physically active, you seem to be better able at performing these tasks, in which that means that you're exerting better attentional control. So in one study that we ran with schools within the Hamilton-Wentworth Catholic District School Board, we entered classes grades 6 to 8. There were about 178 students. And we had them do a series of physical tasks and a series of attention tasks. And we wanted to see how these two related. So these students did what's called a standing long jump. And so you can see you just stand at one end of a mat and try to jump as far as you can to the other end, and then we measure how long you actually jumped. And it's a measure of explosive leg power. And then we also had them do a beep test. Who remembers the beep test? Yes. Well, I remember it in high school. I don't think I did it in elementary school, but what it involves, you usually rent out a whole gymnasium, and you set up pylons about 20 meters apart, and students have to run from one pylon to the other pylon, and there's a speaker that emits a beep, and the beeps get closer together in time so that you have to run quicker and quicker to get back and forth between the pylons. And so obviously, if you don't reach the pylon, I think 3 times, then you're out, or you just get too tired and you quit. And so this is a really good measure of aerobic capacity, so how well your heart and lungs are doing. And so we had students do both of those physical tasks as well as the flanker. We actually used little fish, which made it maybe a little bit more fun for them. And so we related these physical and cognitive measures. And what we found was that for every 1 centimeter increase that you were able to jump further, you had a significant and proportional increase in your flanker performance. So you were able to do that much better. And similarly, for the beep test, if you had a 1 lap increase, you had a significant and proportional increase in your flanker performance. And so mumbo jumbo research talk, what that means is that if you were more physically fit with our indices of physical fitness, you were also better at these attention tasks. And we're not the only researchers to find this. This is a unanimous finding that seems to be occurring in the research, that kids, adults, younger adults with higher physical fitness are better at cognitive tasks, including ones that are specific for attentional control. Now, extending that, yes.
So that'd be long-term physical activity, not the short-term.
Not the short term, which we will get to. That is a great segue in a few slides. So, yes, it's in the long term, so sort of the accumulated physical fitness that you've built up over the years. But we also see that kids who are more physically active also do better in school. And not just kids, we see this with school-age children for sure, but also young adults. So this seems to be something that extends throughout the developmental lifespan. And some of the questions that we have is, why is that? What is changing the brain based on how your body is functioning? And one of the reasons that the research shows is that there's something called neurogenesis, which is just is a fancy word for brain cell growth. And so physical activity, so the brain just looks like a big mush of gray matter, but inside there's 100 billion little brain cells called neurons. And what physical activity does is that it actually leads to the birth of new brain cells. So what you see is that there are more brain cells growing and forming these dynamic networks. And so what we find is a much richer neural network that develops in the brains of people who are more physically active. On top of that, we also know that the prefrontal cortex is important in attention and also obviously in school success, but other areas like the hippocampus, which is a more deep structure, is really important in the formation of memories. And that both of these areas are much richer and denser in people who are more physically active and physically fit. So again, that seems to support that there's a higher density of neurons that grow and that remain in these areas that are really important for learning and success in school. So coming to this point, this research really shows that you can accumulate over a chronic period of time through physical activity. You can really help the brain grow stronger and healthier. And that's evident through multiple repeated bouts of physical activity that you do over the course of your young lifetime or into older age. But what's really exciting and what's more for the purpose of this talk and maybe more interesting to this audience is that we actually see immediate benefits of a single bout of physical activity on attention and potentially learning. And that's when it gets really exciting when it comes to incorporating this into the classroom. So we do see over the course of a lifetime these repeated multiple bouts of physical activity leading to brain health. But again, an immediate bout of physical activity can also have a similar effect. So the next bit of this talk is going to be sharing what that looks like. So a big question in my research program is, can physical activity breaks during learning improve attention and memory? And this is really important because what the research shows us is that attention tends to decline after about 20 minutes into a lesson. And we know that lessons extend 1 hour, 2 hours, 3 hours, however long they go for. So it's really important to identify a technique or a strategy that can upregulate our attention and have a positive impact on the learning environment. And that's where physical activity might be a really promising technique to do that. And so I started exploring this first in university students as well as elementary students. So first we're going to take a look at some of the research that looks within the university classroom, because the demands on what students have to do in both environments are slightly different. So it's important to explore both educational environments. So can physical activity breaks boost attention and learning during a university lecture? That was a big question that I had. So in order to explore this, we had participants watch a 50-minute online lecture. So the participants who were part of this study, they were actually first-year introductory psychology students. And at McMaster, the first-year intro psych course is a blended learning environment, which means that the majority of their course is actually taught with online modules. and some of the other content is just taught with live lectures. So the majority of the way that they're learning is actually through online instruction. So they sat in front of a computer screen and they watched a real lecture that came from their course. And some of the participants were in a control condition, so they had to watch this 50-minute lecture with no breaks. Some of the participants were in a non-exercise breaks condition. So they played computer games about every 17 minutes into the lecture. So we gave them a 5-minute break. We said, you can play this computer game. It was Bejeweled, if anyone knows that game. And then a third condition that we assigned participants to was an exercise condition. So at the same intervals, about 17 minutes apart, these participants participated in 5 minutes of physical activity. So things like jumping jacks, high knees, hamstring kickers. That was experimenter-led. And before each break, participants were asked to characterize their mental state as either on task or off task. And so what we were trying to do was get an index into how much attention they were paying at that given time. So that was sort of our window into their attention throughout the lecture. So the overall experimental procedure, just to give you a full picture of what this looked like. So the first part of the lecture would start for 17 minutes, then they would get this baseline attention probe asking, are you on task or off task? And then they would get their break. If you were in the control condition, you wouldn't get the break, you would just continue with the rest. Okay, the second part of the lecture happened, then the second probe, and then another break, the third part, and then we gave them an immediate comprehension test to see how much they actually absorbed from that 50-minute lecture. And then we sent them away and asked them to come back 2 days later to do a delayed test. We wanted to see if any effects existed at the immediate point if it lasted for 48 hours after. You had a question?
So you did a probe even in the ones without breaks?
Yeah. Yeah, we had a probe, so it just showed up and then they answered for the controls and then they continued the lecture. So if we take a look at some results, so this figure is just showing the attention outcomes. So along the y-axis, you see proportion on task. So it was in each condition, how much on task attention did each condition endorse. And along the x-axis, you'll see the mid-lecture point where the probe was introduced and towards the end of the lecture. So this is just where you on or off task at various points. And if we take a look at just the no breaks and the non-exercise breaks group, we can see that they're hovering, around 60 proportion on task. And you see a typical characteristic drop in attention from about halfway through the lecture towards the end. Now this isn't surprising based on the data. Attention does tend to decline as time on task increases. But what was really exciting is that those in the exercise group, they also started off around the same sort of level as the other conditions, about midway through, but they were able to sustain their attention for the entire duration of the lecture. So they did not see that characteristic drop, which was really exciting to us. It seemed to support some facilitation of attention. But we really wanted to relate this to how did this actually impact learning. So remember we had those comprehension assessments at both the end of the lecture and 2 days later. And you can see mean percentage correct on that quiz. And you can see that for the no breaks and the non-exercisers, they're performing poorly throughout the entire, both immediately and delayed. However, those that exercised were significantly better. And if you extrapolate that out to represent learning in a classroom environment in terms of what they're getting in terms of grades, that's a several letter grade difference that you can have an effect on your students just by virtue of introducing a few exercise breaks, which was really exciting. So we came up with this slogan, which we published, called Sweat So You Don't Forget. I can't take any credit for that. I'm terrible at making titles, but one of the co-authors came up with that. But it was really interesting to see the effect of these short exercise breaks on facilitation of attention and memory. But there's still a ton of work to be done. This was really just a drop in the bucket. There's a lot of questions that we still need to answer. So the ideal environment or the ideal world for me as a researcher is to be able to offer a prescription to teachers or to parents or to anyone who wants to be physically active in a learning environment to facilitate their attention and learning, I want to be able to say, this is what you should do, how many times, how often, and at what intensity. Because when we give drug prescriptions, and by we, I don't mean myself, we have to tell them exactly how much dosage to take, when, how often. All of that information is important. So when it comes to delivering some sort of program that we can offer in a learning environment, we have to know how many breaks are best. That's a really important question, and actually my master's student, she's trying to tackle this question. So how many breaks is appropriate for different learning times? What intensity is best? And we've begun looking at this, trying to modify whether high intensity is really important to get your heart rate really high, or is something lower in intensity just as effective, so you just need to do something that's movement-based. And we're seeming to find that, and I can't speak too soon, but what the results are starting to suggest is that any intensity is good as long as you're doing something. So it doesn't have to be crazy high intensity, which is really nice because it offers some feasible guidelines for everyone to participate. And then what type is best is also a really important question, because there's a whole bunch of different types of activities that you can do in a classroom as well. So where does a teacher even begin to tackle that question? So we're also trying to look at that. So now moving from the university lecture into the elementary school classroom, this is a project that I collaborated on, also within the Hamilton Wentworth Catholic District School Board, and it was about bringing physical activity breaks into the math classrooms of students in grades 2 to 8. So we worked in 3 different schools, again within the Hamilton community. And there were about 426 students that participated in this program. And what we did was a 6-week classroom-based physical activity intervention during math class. So every day for 6 weeks, there were a group of students in classrooms that participated in physical activity breaks, and then we compared that to classrooms that just went about their business like usual. And we wanted to see, introducing these physical activity breaks, did it have any benefit on a whole number of different factors, which you'll see. So we used what are called OFIA physical activity cards. I don't know if any of the teachers use this. Yes, you're nodding. Right, so these are flashcards essentially, and they tell a certain type of physical activity to do. So you pull one out, and if it says jumping jacks, then that's the physical activity that your students would follow. And so we had kids doing this. We rolled a dice. The next slide will actually show the video. So we rolled a dice, and it showed how many of these physical activities they had to do. And they did it for varying amounts of time, which we're not going to get into the details of that, but what you can see here.
5, 6, 7, 8, 9, 10. Okay, who's rolling? Oh, roll. 6. Cross crawl. Okay, elbows to our knees. 1, 2, 3, 4, 5, 6, 7.
So that was just a really cute demonstration of one of the classrooms going through these physical activities, and you could tell they really enjoyed it. They had a great time. It was something that they could step out of their math work and engage in something different. But obviously the real evidence is in the actual outcomes, and that's what we're going to look at. So within this 6-week period of time, we had what's called an acute study. So during the 6-week study, we had researchers go into the classroom at random intervals, and we had students that were picked from the classes before and after their physical activity breaks, or if they were just doing their math classes like usual. We plucked them out of their classrooms and we had them do a few different things. So these students that we removed from their classes, we had them do a few psychological assessments. So we asked them about their affect, so how they're feeling, and how motivated they were to do well on their math learning at that time. We also had them do the Stroop task, again a measure of their attentional control. And then we sent them back to class, and either they did their exercise breaks if they were in that classroom that was assigned to that experimental condition, or they just went about their usual classroom work. Then we plucked them out of class again, and we had them redo the psychological assessments. We also had them do a measure of self-efficacy, which is your belief in your ability to complete a certain task. And it's one of the strongest predictors of how well you do in any sort of physical activity task and how well you do in any educational task. And then we also re-administered the Stroop. So we had this nice pre and post physical activity bout set up. So if we take a look at some of the results in terms of affect, so how students were feeling, what you're going to notice here is this is a different score. So a greater change indicates a greater benefit in a positive way. So you can see that the students who were in the exercise breaks classrooms they had a significant boost to their affect. So they were feeling better after the exercise breaks. If we take a look at self-efficacy, you can see both the controls and the exercise participants did have a boost in their self-efficacy, and it's probably because now the self-efficacy was related to how well they thought they were going to do on that second Stroop task. So obviously some exposure to that first Stroop task, they felt pretty good about it regardless of what condition they were in. But what's interesting is that those in the exercise breaks group, they thought that they had higher self-efficacy for the Stroop task, which is completely unrelated to physical activity, but engaging in physical activity gave them a boost in this psychological process as well. Unfortunately, motivation was not significant. You can see a slight difference with the exercisers benefiting a little bit, but not significantly so. If we take a look at attention now, so performance on that Stroop task, so the congruent Stroop refers to when the color of the text matches the word. So if purple was written in purple. And what we see is that, so a reduction in performance is actually better because this is reaction time. So if you're getting faster, then you should actually see a greater change in terms of a dip. So the exercise participants, so students, did see a greater benefit to their Stroop attention performance after they exercised in their class. And for the incongruent Stroop, so when the color and the text doesn't match, they also saw a benefit, and it was even more magnified. So what these data sort of collectively suggest is that physical activity breaks in an elementary classroom can also help boost attention. Now we're still trying to rifle through the data to see how it impacted sort of their longer term academic outcomes in terms of how well they were doing in math specifically. But just purely attention-based, they were doing better in terms of attentional control, and in terms of the psychological outcomes, they seem to be happier, which is also a really important indicator of how motivated they're going to be in class and how well they're going to do. So a really important question as well that I have is what is actually happening to the brain after you engage in physical activity? So we see this benefit on attention, and we know attention is localized to certain parts of the brain, so there's some sort of natural association that we can make. But I was really interested in actually what was happening to the brain following physical activity. So we have this wonderful piece of technology that I'm going to share with you in a second. It's brain imaging technology that we can actually collect in the community, in classrooms. It's just a little cap that we can put on the heads of students and participants that come into the lab, and we can measure brain activity with this. And it's very portable, and up until now, usually you had to go into a big brain scanner to get any sort of indication of what's happening to your brain. And that's obviously very expensive and non-remote. And so it was very challenging to have any sort of idea what's happening to the brain during that time. But during the 2 Stroop tasks that we have here, we put on this cap onto our participants. So what does this cap do? So it's called functional near-infrared spectroscopy. It's a big, we just call it FNIRS. And it measures blood flow in a certain region of the brain. So you can see that there's these little optodes that sit on the scalp, and they're picking up neural activity in a certain region. But let me break this down for you a little bit more, because I really want you to get an appreciation for the technology. So what happens is you have a source optode that sits on the brain, not on the brain, on the scalp, and you have a detector optode. And so this just sits on the surface of the scalp. And what it does is the source sends a beam of infrared light that gets detected by the detector optode. And depending on how much blood there is in a certain region of the brain, there's going to be a different concentration of light that is absorbed by the detector. And that gives us some insight into how much blood is in a certain region. And like I said before, if there's more blood in a certain region, it means that it's more active, which means that it's doing a better job at whatever it's supposed to be doing. So this was actually one of our student participants in the Acute Study that I showed you, and she's preparing to do a cognitive task here. But yeah, we brought this into the classrooms, and we were able to get a measure of what is happening within the brain during those Stroop tasks. So I actually have some brain data for you, which is really exciting. So you're going to see what the brain response is during the pre-exercise, the incongruent portion of the Stroop task. So the hardest portion of the Stroop task. So before exercise, what was the brain doing? And then you can contrast that to what the brain was doing after a physical activity bout. And what you should be looking for is essentially a heat map. So when there's greater activation within a region, it gets more and more red. So as it transitions yellow, orange, red, that means that there's more blood in the area. So you can see that obviously the brain is working, there's some blood flow in the region. Performance was not as good as post-exercise, we know that, but you can see that there's some activation, not a whole lot. You can't really say anything about it until you have something to compare it to. So if we compare it to the post-exercise, you'll notice a significant difference between how much blood rushes into the region to support performance on the Stroop task during post-exercise. So you can see just visually how much more blood there is within that region. And we also know that they perform better on this Stroop task after they engaged in physical activity. So this piece of technology is really wonderful for giving us a window into what's actually happening to the brain before and after physical activity and how that supports attention and learning. So yeah, we can see that physical activity increases prefrontal brain activity, and that really may be what helps attention. And that could be what's really facilitating a benefit for learning outcomes. So that brings me to towards the end, where I would like to hear from teachers or from parents, from anyone who has kids within the school boards. One of the questions that people ask when I share this research is, well, aren't schools already doing this? No. So we say no, but there was a policy in 2005, daily physical activity policy that was instituted, so over a decade ago, and it mandates 20 minutes of physical activity per day during instructional time should be happening. So that's not necessarily gym class, that's not recess, that's instructional time. 20 minutes needs to be devoted to physical activity. A recent review of how well that policy is being implemented actually found that 50% of teachers don't adhere to the DPA policy. And so despite this existing, and it actually only exists in 5 out of the 13 provinces and territories, so it's not a nationwide mandate that's been adopted. Ontario is one of them. So what are the barriers to implementation? And this is really an important area that I've started to focus on for my own research, because we know a big barrier is a need for prescriptive programs to be offered to teachers and into school programs, which are things like how many, how often, what type, what intensity should students be doing. For sure, that's very important, but what's equally important is we need to understand the barriers and the limitations that teachers face within the classroom to actually implement physical activity. And those, just from my own readings and research, those are things like time restrictions. There's a certain amount of curriculum that needs to be administered and that teachers have to get through. Space limitations can also be a big one. Experience and training on behalf of teachers. That you don't walk into a classroom and automatically know how to administer physical activity breaks. That might come with some training. So these are just some of the things that I've identified through my own experience and research as to why DPA is not necessarily being implemented as broadly as it could be, but I would really love to hear your thoughts on this, because it would really inform my research as well, figuring out not just sort of the prescription that we can offer you, but what are the more feasible guidelines that we can tie into that to make it more likely to be uptaken. So before, I have 2 slides left, so before you're sharing your thoughts with me, I just want to stress that I think one of the best ways and one of the most important ways to approach student success is to really have a holistic approach. So not only to understand the important educational, cognitive factors that are implicated in the learning process, but also in terms of health, because we see that the health of the body is intricately related to the health of the mind. So knowing how to tackle all of these issues within a student population will, I believe, lead to optimal student success. So a huge thank you to all of my research collaborators and my sprouting lab that my grad students took a chance as a new faculty member to come into my lab, so hopefully doing them justice. And friends and family, and I think that friends and family definitely don't get enough credit, because they're the people that we go to and vent to when we've had a long day and it took 3 hours to write 1 paragraph that didn't work out. And so, yeah, I think just collectively I am very appreciative. So thank you, and any questions? Yes?
I think you haven't established a dosage relationship yet with exercise versus benefit level?
Not yet. And dosage in terms of intensity, in terms of
Well,
all of the above?
Those are the 3 factors, like aerobic
Yeah.
versus strength versus...
Yeah, so the type. So we have looked at, and it's inconclusive so far due to our sample size. We didn't have enough participants to make any strong claims, but we have looked at just purely aerobic versus something that's called cognitively engaging. So not just getting kids to do jumping jacks, but getting them to solve a math problem like 5 times 5, and then saying, okay, now do jumping jacks that equates to that number. So you're intricately tying math problems with physical activity, and there is some research that suggests that is the optimal type of physical activity to have. The reasons for that, we're not really sure. Some people say it's because it facilitates those psychological outcomes. It makes them feel better to be able to successfully do 2 tasks at once. But yeah, to be continued. Yes?
Thanks for your talk. Kind of jumping off that point, talking about type, have you investigated at all, like, these are all fitness-based activities, any like games-based activities like that have a bit more personal meaning, social meaning, so we're doing, some problem solving rather than math problem solving, but I mean relationship work,
I haven't personally, but the research does show that game-based, sport-based types of physical activity do promote these sort of cognitive outcomes to a greater degree than purely aerobic. Yeah. So if you can get things that are more interactive and engaging with your students, that does seem to be the most effective.
So you're saying like an optional course would be better than just running around?
Yeah, I think so. For sure, that's what the research suggests. Like I said, I haven't personally been involved in that, but just from my reading of the literature. And they, some of the research calls it coordinative exercises, so things like dribbling a basketball through pylons is something that requires coordination and physical activity, and that's supposed to activate more areas of your brain, supposed to be better for you. Yep. But it's still very much a new area of science. I think because we're getting all these new pieces of technology that are becoming more accessible, that allows us to see into the brain and understand a little bit more. But you're a teacher, I don't mean to put you on the spot, but do you do any physical activity in here?
I can tell you, I was part of a group that went out to the Thames Valley schools probably 10 years ago when that new mandate came out, and we went in and we taught teachers, here's
Wow.
what to do,
Okay.
here's how to do it, in terms of here's some activities
Yep.
that you can do, and other things that you had mentioned, such as time and space, time being the biggest
Yep.
one that a lot of teachers, I don't have time, I have to cover this, that, and the next thing, and are willing to part with that, even though it's mandated.
Interesting. And so you did that like 13 years ago, and then has there been any follow-up or?
No, I mean, it's always been pushed to continue that DPA portion, whether it's basic exercises like you had demonstrated in your video, or other little games that you can play in the classroom. And again, space was one of those things. If they're able to go outside, great. If they had a double gym or something like that, great. But that's not the reality of most of the schools, that there isn't a space for them to go that's clear. And that's what we were finding with the teachers. There are some certainly that are doing it, but certainly not the number that needs to be.
Right. That's fair. Yes.
Well, this recent push to balanced day actually reduces the availability of physical activity for the students.
What is that?
Balanced day schedule, where you have 2 recesses instead of 2 recesses and a lunch. You have two nutrition breaks in the day.
I've heard nutrition breaks. Yeah, when we were doing testing, I wasn't sure what that was, but
Yeah,
that's
it's
the
because-
second.
The same number of minutes though.
It depends who you talk to. But,
It's
yeah.
still the same number of minutes where it doesn't matter what school you go to.
Yeah, well, it was different at our school.
Interesting. So there might also be some lack of consistency maybe across schools. Yeah, I'm not sure about that, but that could also be sort of interfering.
In terms before you were asking about just feedback for like ideas and things like that. So I just graduated from Teachers College, so I haven't actually been in a classroom like on my own yet. But with the associate teachers that I've had, I found that some of them do DPA and some of them don't. But the ones that do, I find that it's more accessible when they can just click a button and it's a prescribed video. So whether it's brainwave, go noodle, things like that, things that they can just say someone else is doing it. I think that works really well. So if you were looking for something to encourage teachers to do that, I would suggest creating like prescribed videos where it's like play this and have the students copy it, and then perhaps like including a list of accommodations for different students with exceptionalities. Because then that takes out any need for the teacher to have training, or like the teacher vulnerability of like doing jumping jacks in front of students, or like their own ability as well. So that's something that I've definitely noticed.
Absolutely, that's a great point. I'm definitely going to think about that some more, because that's sort of the idea. What can we offer to make it maximally used, and if that's the best approach.
Even like also the teachers aren't exerting all of their
For sure.
energy because they're obviously exhausted already. And it also like leaves more time for them to like assess participation and engagement. So they can tell like if they're up there working out, they can't necessarily see like who's doing it, who's not engaged. But if they're sitting and kind of just watching their class, then they can say, oh, so-and-so never participates, what can I do to get them more engaged? And kind of make it more targeted.
That's a great idea. Yeah, that's wonderful. Yeah, I'm going to think about that some more. Anybody else?
Just a question. Have you had kids in your samples with ADHD, and if so, how have they done in terms of this?
Explicitly told to us, no. So not within the kids' classrooms that I know of. But the research on this area with kids with ADHD does suggest that they benefit even more so from some form of physical activity in the classroom. So everyone typically developing benefits, but they even more so. So yeah, and they don't seem to have any sort of barriers in terms of their physical capabilities, but will benefit more cognitively.
I believe there's some research that shows that physical activity is one of the best treatments for ADHD.
Absolutely, yeah, and it's one of the things that we're trying to investigate as well. We're starting a study in the next few months, specifically with kids with ADHD, trying to understand how they respond to a bout of physical activity, and we're trying to manipulate dosage, trying to understand if aerobic or more cognitively engaging is better for them, because they might need some extra stimulation, so cognitive engaging might be optimal for them as well. Yeah, and I think so. Within the Child and Youth Development Clinic, so the director there, Dr. Colin King, mentioned that it's really a 50-50 split in terms of the kids that are medicated versus not. And it seems to be, parents might not necessarily be sure what the best approach is for their kids. Medications do have a lot of side effects in terms of mood for kids with ADHD if they're on it. And it might not be something that they want their kids to be on for forever. So these alternative behavioral treatments that can become habitual could be a really wonderful alternative, yeah. Okay, no, yeah.
So picking up on that, I wonder whether mood is also a very strong mediator of some of your effects. It might go through attention, or mood may affect attention, right?
Yeah,
Because
so
we also know that exercise is a really good intervention for depression.
absolutely. So it's very good for mood disorders or just any sort of mood disturbances. And one of the pieces of research that I didn't share, just for time limitations, is that, so exactly what Daniel was saying, so we see that physical activity helps attention and cognitive function, but it might not be like this. It might not be a direct relationship. So mood is up here, and it might be that it benefits mood, and that's actually what promotes attentional control. So it might be more of an indirect relationship that physical activity has on attention through its benefits on mood, which is also really exciting because it's multiple birds with one stone kind of thing. So you're hitting multiple targets. Yes.
I know you talked about affect, and I think this might just go back. I'm not sure if everybody understood fully what affect was, but I think that's what mood was kind of getting at, right? Between motivation and affect, we were looking at that, and that showed the same trends that you're talking about.
Yeah, absolutely. So we saw a benefit on affect. So affect it's called a feeling scale. So we literally asked them how good or bad they felt. So it's very visceral, very to the point. So we can get a nice index into how they're actually feeling. And affect is a portion of mood. So yeah, so that would be, and that's also something that we look at sort of more holistically, these other measures that are also impacted by physical activity and how they all interrelate.
I have a question. I don't really know much about the curriculum in Canada. Specifically K-12, do they have physical education as a timetable, like a timetabled course?
So I don't know too much about educational curriculum either. I see Jackie shaking her head as yes. We do, yeah.
Okay.
Got it.
Yeah, because
It depends on the school, whether they can schedule it every day. Some schools
Okay.
And not through till grade 12.
Yeah, because-
have to take grade 9 and move beyond.
Right.
Oh, because in my country, I'm from Jamaica,
Mm-hmm.
where it's a timetable thing, where you have to do physical education. So I'm just curious, you know?
Interesting. Yeah, I do know it stops being mandatory at grade 9. That's as far as I know about it. So one of the things that I'm really excited, so I'm predominantly a researcher, which means I live in a hole. So I'm trying to understand more of, the limitations and what actually goes on in classrooms in the real world. Because I think, and that's part of what this is about, trying to communicate what we do from a research perspective to people who are actually on the front lines trying to implement what we're giving to you. So, yes.
What I've seen at some schools is they take their total allotment of physical activity and they put it into bins like every other day on a 6-day rotation or something like that. So if they don't get it every day, they'll just get a whole bunch one day and nothing the next day. And then some days they'll get removed for assembly.
And that's by school? Like
Yeah,
different
it
schools
depends on
decide
the
that?
school, yeah, each school gets
That's
decided.
so interesting. Like I also don't, I'm trying to learn more about who decides how certain things are run per school within a school board. Like there's so much variability, it seems. So it's difficult to also target that way. Yes.
It's in the curriculum, it's mandated, it's allowed to be every second day.
Okay. So, but it
They prefer it every day if you can schedule it that way.
Right.
And I know of one school, and one school only that does it. It's a small school, they have no space.
Yeah, typically it is because of the scheduling. Like if you have a large school, then you just physically can't have all your students in the gym. Like there's not enough time in the day for that. So typically teachers will come up with their schedule and then present it to the principal, and then the principal will kind of work and try and make sure that every class has gym kind of once every 2 days, because otherwise there's just not the space. Unless they go outside, which they do a lot.
Yeah, there's lots of things that need to be thought of just systematically and within the school environment to make it optimal for sure. Yes.
That becomes a little bit of an interesting study to see how they do on gym days versus not gym days.
Yeah, you've got an experiment right there.
That's a great idea.
Yes.
Okay, I've got got 2 research ideas. This was great for me. Thank you.
You can also compare days of indoor recesses versus outdoor recesses.
Yeah, that's also a thing. They say more green space, so outdoor environments are actually more facilitative for cognitive benefits as well.
I think you just get a different level of activity for outdoor recesses. So there's a
More room.
dosage
Yeah,
correlation
there's
there.
some dosage there too. Yeah. Yes.
Going back to university students, I work at Western in residence life, and so the reason I'm here is because I'm part of the wellness portfolio. So looking at improving the physical activity of our students that live in residence, so that it benefits their academic learning and success. So do you have any tips or suggestions on how to engage first-year students that are cramming for exams, and how to tell them to take an hour and go for a walk or do yoga or go to the gym, and have them actually see that as beneficial instead of, I don't have time, I have to study?
Yeah, I mean, what kind of access do you have to them? Do you have them in a room at any given time, or you can?
There's over 5,000 of them.
Okay,
so
there's a lot.
We have at the beginning we have them in a room during orientation week, but then at that point we have basically the way residence works is our students live on a floor, and then each floor has a staff member. So we have student leaders that are distributed, so we kind of tell them the messaging and then they share that. So there are Facebook groups and ways that we can do, poster campaigns and messaging through bi-weekly meetings. But in terms of statistics or things that you can just show students to say, if you do this, then you will do better in school. Just
absolutely. Well, you could create a really quick poster that conveys that message that could be disseminated with whatever means that you have, with some actual science behind it. That might give it a little bit of footing. Yeah, why don't you talk to me after, because it could probably be something that could be put together quite easily. Yeah, and I think so. One of the things that actually a colleague of mine was looking at was whether messaging, providing information about the benefits of physical activity changes people's perceptions of whether they would be more favorable to incorporating or to participating in it during class. And obviously it's a little bit of a contrived study to, ask, what do you think about this? Give them really positive information about it. What do you think of it again? But there does seem to be a little bit of a shift in perspective. So you might not get everyone sort of switching over. But yeah, I think messaging in general and just showing that it's actually based on some real evidence would be a wonderful way to get to them. And it can be very, very simple and to the point. So yeah, reach out to me because I think that'd be easy to put together. Yeah.
I have a question actually from Twitter.
Oh,
just
nice.
Came through. I just tweeted about your talk, and somebody from Notre Dame University in the States is asking you about the dosage, because she says, I'm a little worried about giving up 15 minutes of a 15-minute class, but I can easily give up 3 to 5 minutes. So what would your answer be with dosage?
It's a tough one. So
Or what does the literature say? Is there any literature? I can also say there is no literature.
It's mixed, which is the answer to every research question. So there has been, they're called funtervals, was another study that was done. So those were 4-minute intervals that also showed a benefit to increasing attention and on-task behavior. So that also supports sort of my 5-minute intervention. There's some researchers say that you need at least a 10-minute bout to induce some cognitive benefits. But yeah, I think, and also what we're showing in terms of intensity, which is a part of dosage, is that it also doesn't have to be anything, you don't necessarily have to get up and move around too extensively. So even if it's a 1 to 2 minute seated stretch-based physical activity, that might also be better than nothing. So yeah, I think anything is better than nothing, for sure.
Well, thinking of your first graph that you put up with percentage attention level, I think a way of thinking about that could be that having 80% attention during 35 minutes of a 50-minute class is better than having 30% attention during 50 minutes of a 50-minute class. Right? It adds up to more minutes of attention.
That's true. Yeah, that's a great way to.
You have to figure out the amount of activity versus the amount of attention returned to figure out your break-even point.
Yeah, that's a great point. So one of the studies that my master's student is doing is trying to see how long the effects of a physical activity bout, so sort of tapping into giving participants attention tasks, not just immediately after, but 10 minutes after, half an hour after, seeing how long one effect lasts, because then if you see the effects start to diminish, that's when you know you need to reinsert another break. So that could be one way of looking at it.
You could put like Fitbits or something on all the students, measure their oxygen saturation and heart
Oh my
rates,
goodness.
right? And then you can use that to correlate
Money
activity
fell from
levels.
a tree. And
Well, you know, they have to give them back at the end, right, or something?
Yeah, I mean, those are all great ideas. I think, yeah, I forget what I was going to say, but a lot of this research started off by just teachers would report how much fidgeting there was in class. And when that started to rise and they started noticing that incorporating some physical activity reduced fidgeting and seat shifting, and that's really where this research started, showing that those physical manifestations of inattention were reduced with physical activity. So there could be more subtle ways to do that, but Fitbits and those kinds of things.
So it comes on some phones now, right?
It does, yeah. I feel like that'd be a problem asking kids to take out their phones in class. I feel like they're trying to get away from that, but yeah.
There's actually just with what you were saying with Thames Valley, we're part of another subgroup with pedometers, so we're putting pedometers on kids and having lots of different challenging activities for them, but also making it curriculum based as well. So there are lots of opportunities for them to be moving and grooving, and I did it last year for a month, and then afterwards the kids were, you know, when they weren't wearing them.
Really?
Yeah, they missed it, which
yeah,
was
it's
really
kind of
interesting.
like you have some sort of, what's the word for it? Accountability when you have a pedometer. Like it's sort of like you're playing a game that you're accountable to certain numbers of steps, and it's a little bit of a competition too. Yeah, so I am trying to get funding for Actigraphs, which measures sort of physical activity as well as sleep measures to sort of prolong the assessment of how physical activity and more or less of it in a school, how it impacts other functions such as sleep, which are also really good for brain function. And but yeah, those kinds of initiatives are really interesting.
We certainly found that the kids, when they were wearing them, were more active. They had more steps than when they didn't. You could just physically see.
And how long did you do this for?
For a month.
Okay, so it didn't like diminish after 2 days when they were like,
No. I mean, the first couple of days were
For
crazy,
sure.
as you can imagine, but after that, they kind of got into their.
And you noticed a significant decline after.
Absolutely. Yeah.
How to
Fascinating.
measure their steps when we weren't wearing them, though?
Well, you don't, honestly, but just looking at how busy they are during the day when they have them on, because they know that this counts, and they'll be standing in line like this.
That's so funny.
You don't even have to practice them then.
No.
Well, Barbara, I think all the questions and ideas that
Yeah,
you've
they're
given
great
really,
ideas.
Yeah, they really point to what an interesting topic this is and how relevant it is for teaching kids and adults. So thank you very much. It's just the bag. There's actually. So if people want to hang around for a few minutes afterward and ask questions, is that okay?
Yes.
Okay, so before you go, we have another of these talks coming up in February, and keeping with that theme of doing things, right, and not just listening and reading and so on. The next talk is going to be in the maker space, so it will be across the hall in the children's library. And Dr. Immaculate Yamakasa is going to be doing a series of activities on robotics. So if you have kids, bring them. You'll have a chance to rotate around and play with robots and learn about education with robotics.
Can I play too?
You can. Come. You can play. Also, if you're here tonight and we don't already have your email address, then we'll ask that you leave your email address on the way out. I want to thank a couple of other people who have helped us tonight. I want to thank Devin, who's been doing our AV, so thanks, Devin. And also Jen Heidenheim at the back from the Faculty of Education organized the event this evening. So thank you. We still have a pile of cookies at the back, so please take those with you. We don't want to take those home with us, and I hope we'll see you again in February. If you would like to stay around and talk with the researcher, you're welcome.